Welcome back to the laser system tutorial. This is the second and final part. Last time we left off with a simple laser spawn and a laser target. Now we're going to get into the reflect and a cube to reorient the laser. We're going to be starting off in the laser parent, so open that up. Once we're inside, we're going to create a function called clear all lasers attached. We will be using this function when we lose contact with something like a cube. We start off with a for each loop and our lasers attached array. From the completed branch, we want to drag out and clear our lasers attached. From our loop body, we want to check if our laser is valid, and if it is, we want to destroy actor. Once you're finished, you can close the laser parent because we won't be using it for the rest of the tutorial. Next, we can open up a laser, and inside we're going to create a variable of type string called laser ID. Laser ID is crucial in how we're going to remove the lasers as we go on. We also need to make sure that it's exposed on spawn. Next, we're going to create a very simple function called update ID. We're going to need a reference to laser ID, to which we're going to append a string, which will then return as a string in the output. We can rename the parameter append. The way we're going to use this function is every time we create a new laser via a cube or it being reflected, we're going to add a new value to this string with the append. As such, every new laser will have a new ID, and any ID that happens to exist before that one will be able to interact directly with it. Open up laser spawn and go to our spawn actor A laser and simply attach our ID into our new laser ID. Now we can create our next actor, which is going to be the reflect laser. Remember to create it as a child of the laser parent. We're going to start by opening up our new actor reflect. As usual, we start off by setting up a static mesh. This time we're going to use a simple cube. Any one of the cubes available will do. We're going to change its position so that it's relative to the ground, and then we're going to resize it so that it feels more like a wall or a mirror. Once you've finished repositioning and resizing your cube, feel free to drop it in front of your spawn laser. Put an angle on the reflect so that it doesn't send the laser right back down the one it came from. We can run the project to see if our new actor is indeed blocking the laser as it should. We're going to be setting up our laser reflect now, and to start off we're going to have to set up our blueprint interface. Open up class settings, go down to interfaces and add our BPI lasers. Open laser bounce. We'll start off with a branch and use hit result as the condition. We'll start with true and drag off and call spawn actor from class. We're just going to give ourselves a bit of extra space to work with. The class we'll be using is a laser. Once we've selected it, we want to then split the transform. For laser ID, laser color and spawn reference, we'll be getting those from the laser hit parameter. Search for spawn reference, then laser color, and finally update ID. Although there's a small issue with our function update ID, we want it to be a pure function, so we're going to change that in a laser. Detach laser ID from update ID and set parameter to B. The value we have for the append can be any character as long as it's different between the cube and the reflect. Next is the transform of the new laser, so we want to get hit information. Then we break hit information. And we want to get impact point for transform location. For the rotation, we're going to need impact point, impact normal, and trace start. We're going to subtract trace start from impact point. Then we search for mirror vector by normal and attach impact normal to in normal. To finish off, we make rotation from Z and we attach it to spawn rotation. Next, we're going to collapse these nodes. Later on, we're going to collapse them to a function because I realized that we needed them outside of our reflect blueprint. So you can do that immediately or wait until I do it later in the tutorial. Next, we're going to be adding our new laser to the different arrays within the blueprint. We'll start off by searching for get lasers attached, drag off and type add, and attach the return value to the node. Next we'll be doing the same but with the spawn reference. We can get the reference we want from the laser hit, so copy what we have before. Drag off and type get child lasers. Make another add node and attach our new laser. To finish off the true branch of the function, we'll just attach our new laser to its output new laser on the return node. Next up, we're going to do the false part of the function. We're going to drag off and search for clear all lasers attached. But sadly, due to how clear all lasers attached works, we're not actually going to be able to use the function that we made to act as the hit response false in the reflect. The reason for this is because the reflect can have multiple lasers from different sources and we don't want to remove them all if just one gets disconnected. So we'll simply create a new function we'll call the attached lasers. The function will be almost identical to the previous one we had. So we'll start off by getting our lasers attached and plugging them into a reverse for each loop. Next we want an isValid statement from the array elements. So drag and type isValid. This is where we'll start to see variation, as we won't just be deleting the laser, we also want to check its ID. From the array elements, search for laser ID. Next, create an input to the function called idClear and set its type to a string. We're going to be comparing this string to all the laser IDs within lasers attached. To do so, we're going to start by getting a reference to idClear, drag from laser ID and search for contains and attach idClear to the substring. Connect the result to a branch node. Drag from array elements all the way to the branch. If the branch is true, we want to call destroy actor. The reason we chose a reverse loop is also because now we can remove actor from the lasers attached. So search for lasers attached, drag and search for remove item, attach the array element to the remove node. And that will do it for our custom clear attached lasers for the reflect. Now we can go back to our laser bounce function. Once inside, we simply grab our clear attached lasers and connect it to the false. For clear ID, we grab our laser hit and get laser ID. That will do it for laser reflect. Be careful when running the project at this point in time, as the laser spawn system hasn't been updated to take into account reflect, so it's going to be spawning infinite amounts of lasers. But when we do run the project, it does seem to be functioning. Just don't let it run for too long. Additionally, we can also test to see if when we put a cube in front of the laser, does it remove the reflect as well. After running the project, we can see that the reflection does disappear when the cube is in the way. With the test of laser reflect out of the way, we can now close it as we won't be using it anymore. Now we want to start preparing our final actor. Start by creating child from a laser parent. Call the child laser cube. Once you finish naming it, you can open it up. To start off, we're going to set the static mesh to a chamfer cube. Then we're going to go add an arrow component for the direction of the laser. Once the arrow is there, we want to move it outside of the cube. Next, we're going to uncheck the hidden in game box for easier debugging on the arrow. Feel free to add the actor to the level. We need to go back into the laser cube and on static mesh simulate physics. We can start by just removing the events in the event graph as they serve no purpose. Next, we're going to set up our BPI lasers again, so open class settings and select add interface BPI lasers. Open up laser bounce. Start the function off by dragging from laser hit and searching is valid. If it is valid, we want to drag from laser hit and get spawn reference. Search for set spawn reference and drag the get spawn reference into the node. Next, add a branch. Now we're going to make a condition to ensure that the function laser bounce isn't called an infinite amount of times but only once on changing between true or false. We start by making an AND node. For the AND node conditions, first we want hit response. For the second condition, we want to get active, followed by the not node. We then want to drag from the and search for the OR boolean. For the second condition of the OR node, we want to get hit response again and drag out and search for the not boolean. Editor's note, the condition you just created is not necessary as we'll be dealing with that in the A laser directly. Get hit response and search for set active. Add a branch and attach active as the condition. From false, we want to drag out and search for clear all lasers attached. Next, we're going to make a bit of space for the true statement. Start by searching for spawn actor from class. Attach to the true and then select our class A laser. Split the transform. We start by searching for get laser hit, followed by spawn reference. Attach spawn reference to spawn reference. From laser, get laser color and attach it to laser color. And finally, from laser hit, get update laser ID. Attach it to laser ID and set the append value to C. Up next is the transform. Start by getting our arrow component, search for get world location and attach it to spawn location. Next is the rotation. We're going to start by getting the arrow component again. From the arrow component, we want to get forward vector and then make rotation from Z and attach to spawn rotation. So before we add this new laser to our arrays like we did for the reflect, we need to attach it to our cube. To do so, we're going to search for attach actor to component. The parent will be our static mesh parent. As for the rules, we want to set location rule to keep world, we want to set rotation rule to keep world, and leave scale as relative, and uncheck weld simulated bodies. Now we drag off from our new laser and search for add. Then we get attached lasers and connect to the add. Now we get spawn laser, and from it we get child lasers. And we use add once again for the new laser. To finish, drag the new laser into the return node. We can open up the editor now and move our cube in front of the laser so we can test if it functions correctly. Let's run the level. Everything seems to be working fine. Let's see what happens when we cut off the laser to see if it stops itself. And it does, it stops correctly. And it restarts once the laser hits it again. Right now everything might seem like it's done and perfectly functional, but I'm going to show you why we still need to rework the A laser to make it function completely. So as you can see, once we have a reflect into a cube, everything works fine. But errors start occurring once you start disconnecting lasers that are indirectly connected to the spawn. Like here, for instance, where the laser from the cube is still going even though we've blocked the laser from the spawn. So to fix this issue, we're going to have to go into A laser and kind of overhaul the whole system we'd made before. Once you've opened A laser, go into set endpoint if it isn't already open. Disconnect everything after the set world scale 3D. Create a new function called cancel target hit. Cancel target hit needs to take in one input, which will be a boolean we can call override. We also need to add an output of type boolean. Set the name of the return value to remove from array. We're going to be starting off our function with a sequence. For then one, we want to get last hit actor and convert to a validated get. We then want to cast last hit actor to laser parent. We now want to make a distinction between those that can use our interface and those that can't. So we'll do a does implement interface. Select BPI lasers. Add a branch node. Before connecting the branch and the does implement interface, we want to add an AND node. From laser parents, get lasers attached and drag from that and check is empty. Attach is empty to the second AND condition before attaching the AND to the branch. If branch is true, we want to get last hit actor and call laser bounce. Set laser hit to self, leave hit response as false, and leave hit information as is. On branch false, we simply want to set active as false. So drag from laser parent and search set active. Return to the sequence, and for the second pin, drag off a branch. The condition for the branch will be the override input. On false, we want to search for destroy actor and set remove from array to true. On true, simply add the return node. That does it for this function. Now we're going to move back to our set endpoint. After set world scale 3D, add a branch. For the condition, get L hit actor and get last hit actor. Actually, scratch that and simply get L hit actor, convert it to a validated get. Get another reference from hit actor, drag out and search for does implement interface. As usual, set the selected interface to PPI lasers. Drag a branch from is not valid and attach it to does implement interface. Everything past this is not valid is incorrect and needs to be changed with what I'm showing on screen now. You will need to create an additional variable called bounce laser, which is of type A laser. Make sure it's not a local variable. For the isValid, we're going to start off with a sequence node. On the second pin, we want to set last hit actor, and we want to set it to L hit actor. Then on the first pin, we want to set a branch. For the condition, we will get last actor and get L hit actor. Drag from last hit actor and type double equal, and attach it to the condition. If the condition is true, we only want to interact if it is a reflect. To do so, we grab last hit actor and cast it to laser reflect. Now, due to the next functionality we need to add, we need to go back into reflect and turn our condensed nodes into a function. Open laser reflect and go into laser bounce. Once you've found the calculate rotation collapsed graph, you want to right click and expand nodes and then collapse to function instead. Set the function name to calculate rotation, convert to a pure function, and then let's rename the inputs. Rename A to impact point, in normal to impact normal, and finally B to trace start. Once you're done renaming, we can move back to our A laser. What we're going to do now is we're going to change the rotation and location based on the current laser hitting. We start off with set actor location. We get hit information, then break hit results, and set new location to impact point. Set the target of set actor location to bounce laser. Next up is setting the bounce laser rotation. Start with get bounce laser and then search for set actor rotation. To calculate the rotation, we're going to use our function calculate rotation from laser reflect. So from our cast, we want to get calculate rotation. Then we will copy hit info and the break hit results. Connect the corresponding hit results to the corresponding inputs in calculate rotation. Now we're going to look at how to respond to previous actor and current hit actor being different. On the false branch, we're going to start with a sequence. On the first execute, we're going to get last hit actor and check does implement interface. Add a branch to does implement interface. On true, we want to get spawn reference. But before we go any further, we're going to have to create one last function inside of laser spawn. So open laser spawn and create a function called remove following lasers. The function will take an input called laser reference of type A laser. We can quickly go back to our A laser and call our newly created function. Set laser reference to self. Before returning back to our remove following lasers, we're going to do the second part of the sequence. For the second part of the sequence, we're going to copy our does implement interface above, but we want to replace our last hit actor by L hit actor. On true, we want to call the laser bounce function. We can copy another version earlier, just make sure to use L hit actor as the target. Set bounce laser to the new laser created. We've now finished with the logic inside of A laser. We just need to finish our last function inside of laser spawn. Double click on remove following lasers to open the function. We start the function off by grabbing from laser reference the laser ID, then promote to local variable called LID removed. From there, get child lasers and attach it to a reverse for each loop. Drag off array element and search is valid. Next, we want to get laser ID from array element. And check if it contains ID removed. In addition, we also want to check if laser ID is exactly equal to ID removed. To check this, we grab our laser ID and our ID removed again and search triple equal. We use the contains return value for a branch. On true, we want to drag from the array element and call cancel target hit. We set the override to the exactly equal. Use the remove from array to make a branch after. On true, get child lasers and remove item. The item to remove will be the array element. With that, we've finished all the blueprints for this tutorial, and now we just need to test if it all works. Let's run the project. When we run the project, the lasers are spawning as they should, no problems. So let's try and block the laser with the cube and see what happens. Unlike before, all the lasers turn off this time. I'm going to run a few more tests now, moving the cube in different areas and seeing what happens. While those tests are running in the back, I wanted to say thank you for following the tutorial. This is the last part of everything that is functional. I might be making a bonus part to do more stuff like aesthetics and sound effects for the lasers. Let me know if you liked the video or didn't like it in the comments so that I can hopefully improve if ever I make another one.